Good day everyone. I am Riza Rondina and I will discuss the solution to problem number 4 of the second homework. The problem states that if a p-variate normal distribution with mean mu and the identity matrix as its covariance derive the likelihood ratio test for testing H null mu prime mu equals 1 using a sample of size 1. We let a vector x follows a p-variate normal distribution with mean mu and the covariance identity matrix. The likelihood function for a sample of size 1 is given by the following equation. We first derive the maximum likelihood estimator of mu under H null mu prime mu equals 1. We take the logarithm of the likelihood function to obtain the MLE of mu under H null. Then we arrive with a log likelihood function as follows. Maximizing the log likelihood function with respect to mu is the same as minimizing the only term containing mu, which is quantity x minus mu prime times quantity x minus mu. Subject to the constraint mu prime mu equals 1, we introduce the Lagrange multiplier theta, then maximize the following Lagrangian function. Note that the first term of the Lagrangian function is the only term in our log likelihood function containing mu, and the second term is technically just 0 multiplied to the Lagrange multiplier theta. Solving for the derivative with respect to mu, we will use the following properties from the matrix cookbook. To obtain the derivative of the first term of the Lagrangian function, we follow property 86, and for the second term, we follow property 81, where we let mu be the vector S and identity matrix the B. So we arrive with negative 2 times quantity x minus mu plus 2 theta mu, and the derivative with respect to theta is mu prime mu minus 1. To obtain mu, we equate both partial derivatives to 0, so we arrive with mu hat equals 1 over 1 plus theta multiplied to the vector x, and mu hat prime mu hat equals 1. Solving for the Lagrange multiplier theta, we substitute mu hat to the equation mu hat prime mu hat equals 1. Note that x prime x is scalar, so we can divide both sides by it, and then we arrive with theta equals square root of x prime x minus 1. Substituting the value theta in mu hat, we obtain x over square root of x prime x. Therefore, the MLE of mu under H null is x over square root of x prime x, and from proposition 3.1.2, the MLE of mu under the unrestricted parameter space is x bar. However, for sample size n equals 1, x bar equals x, so mu hat equals the vector x, and the likelihood ratio test statistic is given by the maximum of the likelihood function under H null mu prime mu equals 1 over the maximum of the likelihood function under the unrestricted parameter space. For the numerator, we substitute the MLE of mu under the constraint mu prime mu equals 1 in the likelihood function, so we have 2 pi raised to negative p over 2 times the exponential of negative 1/2 times quantity x minus x over square root of x prime x transpose times quantity x minus x over square root of x prime x. And for the denominator, the unrestricted MLE of mu is x, so we have 2 pi raised to negative p over 2 since the exponential term is equal to 1. So the likelihood ratio is given by 2 pi raised to negative p over 2 exponential of negative 1/2 times quantity x minus x over square root of x prime x transpose times quantity x minus x over square root of x prime x all over 2 pi raised to negative p over 2. Cancel out 2 pi raised to negative p over 2. And since square root of x prime x is scalar, we can multiply the two denominators. After obtaining the transpose of x times quantity square root of x prime x minus 1, we get a scalar x prime x in the numerator. Canceling out x prime x both in the numerator and denominator, we arrive with our likelihood ratio lambda of x equal to exponential of negative 1/2 quantity square root of x prime x minus 1 squared. We reject H null if lambda of x is small, that is, if x prime x is large. We know that X follows a p-variate normal distribution with mean mu and the covariance identity matrix. From proposition 3.2.51, x prime x follows non-central chi-square with degrees of freedom equals p and non-centrality parameter equals mu prime mu. However, under H null, mu prime mu equals 1. Therefore, we reject H null at significance level alpha if x prime x is greater than the chi-square with degrees of freedom p and non-centrality parameter 1. Thank you for your attention.